All right, folks, let's get started. Good morning, everyone. My name is Vikram Venkatraman. I'm a Principal Technical Account Manager here at AWS. I've been with AWS for 3 years and 5 months, where I support our enterprise customers. And I also focus on some of the container services that we have and some of the open source observability services we have for our customers. Thank you once again. And the topic for today's session is, you have a container image, and now what? So in the next 60 minutes, we'll try to navigate between the different container portfolios we have, and we'll help you guys to pick a right container service to launch your container image. Of course, depends on your use cases, and depending on your use cases and requirements, we'll try to help choose a container service to launch your container image. Now, I'm not going to bore you with all these statements here that kind of dictates why containers have become the new normal. I'm assuming that since you guys are already here, you already have a container image with you, and you would want to identify that container service which can help you launch your container image on AWS. So why containers is definitely not the topic for today's session. Now, before I talk about the various container portfolios and help you choose the right container service to launch your container image, I wanted to talk about our customers. So our customers are very broad and diverse. So they come from a different background. They come from different industries. So the levels of maturity when it comes to adopting cloud services or even container services is also diverse. For instance, some of our customers like the simplicity nature of the container services. So when I mean simplicity, they might not be having a big operations team that can help manage the container infrastructure for them, right? All they care about is they have a piece of code with them. They would want to deploy this code on the AWS environment and forget about where this code is running. So that's simplicity, and that's one of the dimension. And some of our customers like the flexibility nature, right? They might have some unique application requirements which might mandate them to move between different platforms. So the so-called container services should help them or should be flexible enough to move this application between different platforms. So that's one dimension. And some of our customers also like the agility, right? For them, like I said, speed is what matters, right? They have this piece of code. They would want to deploy this code into the AWS infrastructure and forget about it. They don't care about where this container image is running, or they don't have the ops power to manage this infrastructure. And some of them like the hybridity. Again, security requirements, compliance requirements that might mandate them to have this application run on various platforms. So they might be running a different cluster on premises, and they would also want to run this so-called application on the AWS infrastructure. So depending on these various dimensions, our customers try to prioritize and try to pick up the container service that kind of satisfies their needs. So long story short, there is no single container service that can satisfy all these requirements, right? And that's precisely why we have so many services under the container portfolios, and we help customers pick the right container service to launch their container image. So the challenge and the goal for today's session is to authoritatively tell our customers that given their requirements, given the use case, given the various scenarios they have, this could be the right container service for them to launch the container image, right? So I used to think about the whole scenario, right? If you ask me to pick a right container service to launch my container image, kind of think about building a checklist to land a Boeing 747, right? No one will be happy to board this flight if I build a checklist to land the Boeing 747. But like I said, it's going to be a huge challenge. There is huge risk involved in authoritatively telling our customers that, hey, go with this container service in order to launch your applications. But if we know where our customers are coming from, if we know their background, if we know their dimensions that matters the most for our customers, we can come up with some kind of a checklist, like we said, landing the Boeing 747 to help customers identify that right container service. So there are no 17 or 32 ways to run containers on AWS. This is going to vary, the way you can launch your container image on AWS is going to vary depending on your dimensions that we discussed about in the previous slide. So I would request you guys to picturize the various container portfolios that we have to fit into one of these 4 buckets, right? The first bucket we have there is a bucket where you can bring in your own generic container image, use one of our AWS services, and launch that container image on the AWS environment. Now, examples of this bucket includes Amazon ECS, Amazon EKS, AWS Lambda, AWS App Runner. So you could use one of these services to pick your arbitrary or a generic container image, be it Nginx, Tomcat. Use that services to deploy the container image on AWS. Now the bucket 2 is somewhat similar to the bucket 1, but it comes with some value add-on, right? Examples of this bucket include AWS Amplify, AWS IoT Greengrass, Elastic Beanstalk, etc. So we've seen customers picking AWS Amplify to launch the container image, not because it allows you to run container image, right? The customer might already be they might be using this service to build their front-end app or even their mobile application, and they are somehow comfortable using this AWS Amplify, because they have built the other application components. And also AWS Amplify, since it allows you to run container image, they might be picking AWS Amplify to deploy their container image. So long story short, this particular bucket has certain AWS services that lets you run container image that you bring, and it also has some value add-on. Now the third bucket is where you cannot run your generic container image. It doesn't allow you to bring your own container image and make them run on the AWS environment. Examples of this bucket includes Amazon SageMaker, Amazon EMR. So if you think about these services, you can run container images on these services, but the services allows you to run container image in the context of the product itself. For instance, let's think about tuning your machine learning model, right, using SageMaker. You can bring in your own image, but there are specific instructions on how you can run this container image on Amazon SageMaker. Again, long story short, with this bucket, you cannot have your generic container image, you cannot bring your generic container image and have them run on the AWS environment. They have some specific use cases, they have some specific ways, there is a prescribed way on how you can deploy the container image on the AWS environment. And finally, the fourth bucket, where you don't see the containers, because the AWS service itself is built on top of the containers. For example, if you've used AWS App Runner or Amplify, you cannot see, or it doesn't let you run the container images, right? So once you deploy an application using AWS App Runner, everything happens behind the scenes, as in the AWS infrastructure itself, and the customers don't get visibility into what's happening, how your application is being deployed. So basically, the service itself leverages containers and is built on top of containers. As you can notice, there are few complexities that is there in this particular slide. For instance, AWS App Runner fits in both bucket 1 and bucket 4. And similarly, AWS Amplify, it fits in both bucket 2 and bucket 4. And this is where building the checklist for landing your Boeing 747 comes into picture, right? It's not easy to pick a particular service and launch your container image on AWS. And another thing I wanted to talk about is, like, in the fullness of time, eventually down the line, almost all of our AWS products might be leveraging container services. They might be built on top of the container services. So we're not going to focus on the bucket 3 and bucket 4, where a customer cannot bring their generic container image and have them deployed on AWS environment. Instead, we'll be focusing on the bucket 1 and bucket 2, where you can bring, which pretty much answers our question, right? I have a container image, I want to deploy this container image on AWS, and tell me how I can do it. So we're going to be focusing on the bucket 1 and bucket 2 for the rest of the sessions. All right, now we have fit our the container portfolios, the different services that we have into four buckets. Now, what are my options available to run containers on AWS? Before I talk about the services that we have to run your container image on AWS, I would like you guys to think about the whole mechanism as a three-layer process, right? You have capacity in the bottom, you have orchestration in the middle, and you have provisioning at the top. Now, capacity is where you package the containers with the CPU memory requirements. Basically, it's the infrastructure where your containers is going to run, be it Amazon EC2, Fargate, on-prem servers, or even edge locations, right? So capacity is where your containers is going to actually run. And orchestration is the middle layer. Obviously, if you're running containers in a production scale, you'll be running more than one replicas. And let's say you have 1,000 such containers running across 30 Amazon EC2 instances. It becomes a nightmare to manage such a complex environment. So definitely you might need orchestrator that helps facilitate, that helps deploy your application and manage the application on your behalf. So that's where the orchestrator layer comes in, where it kind of manages your container running on the AWS environment. And on the top, you have the provisioning layer. Think about provisioning layer as a set of provisioner tools that can interface or interact with the orchestrator layer, right? Because each orchestrator comes with its own complexity, it has its own richness, and we would like to hide the richness or complexity and make it easy for our customers to consume the service, right? And that's precisely why we have provisioning layer, which is nothing but a set of provisioner tools that you can consume to interact with the orchestrator and eventually deploy the container image on AWS environment. Now that we have the three layers in place, what are the services that I have that I can leverage to run container image on AWS? So for the capacity layer, we have Amazon EC2, like I mentioned. You have AWS Fargate, and thanks to the announcement of EKS Anywhere and ECS Anywhere in the last re:Invent, we now can use the same AWS APIs to deploy container image on on-premise servers as well as edge locations. So which means that we have, you could use Amazon EC2, you could use AWS Fargate or on-premise servers, edge locations to deploy your container images. In the middle, like I said, we have the orchestrator layer, Amazon ECS, Amazon EKS, and Red Hat OpenShift on AWS, which is a managed way of running OpenShift cluster on AWS, are the three orchestrators that we have that can help you run container image on AWS. Now, Red Hat OpenShift on AWS is a wonderful collaboration between AWS and Red Hat, which kind of gives you a managed way to run OpenShift cluster on AWS. And on the top, you have the provisioning layer where, like I mentioned, it's a set of tools. It's a group of provisioner tools that can interface with your orchestrator, and it can help you run container image on AWS. So Docker Compose, AWS App Runner, Copilot, we'll be seeing or we'll be talking about these tools in just a minute, but these are some of the provisioner tools that we have that our customers leverage to run container images on AWS. And as you can see, we also have AWS Lambda, which is kind of weird in a way that it kind of encompasses all the three layers into a single service, right? With Lambda, you don't need a provisioner tool. You don't need an orchestrator because Lambda doesn't use an orchestrator, or you don't know where your container images are running. We know that Lambda allows container image. It lets you run container images on Lambda, but there isn't any provisioner tool or orchestrator or capacity that comes into picture when you use Lambda. So it's kind of a weird, unique way use case where it kind of encompasses all the three layers into a single service. So these are some of the services that we have in scope belonging to each of these layers that customers can leverage to run container image on AWS. Now, one another way to look at the so-called layers and the services that are in scope for each of these layers is how they interact with each other to deploy the container image on AWS. So in the bottom, in the capacity layer, you have edge services, servers, Fargate, EC2, and you have ECS, Amazon ECS, EKS, and ROSA, which are your orchestrator layer. And then you have Lambda, which kind of encompasses everything into a single layer. And on the top, you have the various provisioner tools that you could use to launch container image on AWS. Now, if you remember, we talked about the different dimensions, right? Think about the simplicity dimension, where I was talking about a customer who doesn't have a strong ops team, who doesn't have the bandwidth to manage or support the environment where your container image is running. Now, look at the dotted lines. So those are actions or activities that happen on the AWS side, that happens within the AWS infrastructure, for which the customers don't have visibility or access to. And the solid lines are where the customers basically know what's happening because it all happens in their account. It happens in their own AWS accounts. So for instance, if you use App Runner, AWS App Runner to launch your container image on AWS environment, our customers pretty much don't get access to what's happening behind the scenes. This is where the simplicity dimension comes into picture, right? So you use App Runner to launch your container image. You don't have to worry about which orchestrator we pick, where your container image is running. It is all taken care by the AWS, right? And on the other hand, if you use AWS Copilot to launch your container image on AWS, Copilot pretty much creates a CloudFormation stack, which eventually provisions the ECS cluster, and then it deploys your container image on Amazon ECS. So you have access, or you have visibility to what's happening, the various events. So you could hover over the CloudFormation console, and you could see the various resources that are being created when you fire the Copilot command. Now, another thing I wanted to talk about is, when it comes to picking a particular service to launch your container image, we see two types of discussion happening within our customers. One we call the strategic discussion or the strategic analysis. So there will be a platform team that kind of sits together. They will brainstorm and pick a particular orchestrator to launch your container image. Right? That's what we call the strategic analysis or the strategic discussion. And then you have the tactical analysis or the tactical discussion, where your set of developers sit together and identify the right provisioner tools to deploy their container image on the AWS environment, right? Now we'll look into, we'll talk about how they kind of arrive at a particular tool, or how do they choose a particular orchestrator to launch the container image. But one thing I wanted to call out is, AWS Fargate is not a way to run containers. There seems to be a little bit of confusion around using Fargate to launch the container image, but I wanted to clarify that. AWS Fargate is not a way to run containers on AWS. Let me switch to my obligatory slide on what AWS Fargate is. Let's take a look at what AWS Fargate is from the perspective of the orchestrator. The role or the function of the orchestrator is to perform it has basically two functions. One, it models your application. It models your application as pods or tasks. So in EKS world, it's called pod. In ECS world, it's called task. So basically, it models your application. It deploys your application as pods and tasks. And you have services and deployments which are, kind of everything related, built around your pods and tasks. And this is a northbound set of activities that happen, right, with your orchestrator. Now, if you think about the southbound activities, it's basically your capacity layer, right, where your container images are being instantiated. It's basically nothing but a cluster of Amazon EC2 instances, in AWS world, where your container images are being deployed and where they run with their specific CPU memory requirements. Now, what exactly is Fargate? Fargate is a managed compute engine which eliminates the need to manage the cluster of EC2 instances. If you remember, it's called worker nodes, right? If you have a set of EC2 instances on your EKS cluster, we call it worker nodes, and in ECS world, it's called EC2 container instances. But what Fargate does is, what Fargate brings to the table is, you don't have to manage the cluster of EC2 instances where your application pods or your application tasks are running, because AWS is going to take care of deploying these things into the AWS infrastructure, and customers' operation works or operation efforts are reduced. Now, again, let me come back to my original discussion, which is Fargate is not the way to run containers. Because if you log into the AWS console and if you look for Fargate, you might be disappointed because there isn't any service called Fargate. If you are using Fargate to launch your container image, your entry point is always your orchestrator. So Fargate works with both ECS and EKS. So if you're planning to run your container image on a Fargate environment, then you basically gain access through the orchestrator. You can have this tasks run as a, under the ECS capacity, ECS Fargate mode or EKS Fargate mode in the case of pod. So which is exactly why I'm saying Fargate is not the way to run containers, but it's actually a compute engine. It's a managed compute engine which eliminates the need for you to manage the cluster of EC2 instances. Now we kind of spoke about the various capacity options that we have to launch your container image. Now let's look into the strategic discussion that I was talking about, where your platform team builds the orchestrator. They pick the right orchestrator and basically build a framework which can then be consumed by the developers using appropriate provisional tools to launch your container image. Now before I start talking about the various orchestrators and how you pick the right orchestrator for your use case, let's talk about what a container is. For me, a container is a container image that has a piece of code, that has the memory CPU requirements, that has the libraries and binaries binded together, and instantiating this container image is going to run my container or a long-running traditional application, right? So that's container. So container is basically my long-running traditional application that continues to run on my infrastructure. Whereas when it comes to the whole point of this slide being, we pretty much get asked about, should I go with Lambda or should I go with EKS as a choice of my orchestrator, right? How do you kind of debate over which orchestrator service you might be choosing for launching your container image? So the way I see it is, container is typically a long-running traditional application, and when you have Lambda as a way to run your container image, the way I see Lambda is, Lambda allows you to run container image. It allows you to wrap the Lambda function as a container image, and you can launch this container image on Lambda, but the line of demarcation is very clear, guys, right? Think about the long-running traditional application and think about the application that runs on Lambda. Lambda is a serverless, event-driven application, right? Like, if you think about running a traditional long-running application on a Lambda, I would, if you ask me if I can do it, my answer might be no, because as we know, Lambda is an event-driven serverless application. So an event has to happen in order to instantiate this Lambda function, which kind of prevents me from running the long-running traditional application on a Lambda platform. Another way to take a look at how this whole thing is explained here is, think about the traditional application again, guys, right? You have the traditional application that's running on the Amazon ECS cluster, and this is like a request-response-based application. You get a HTTP request, the application responds back. You get another request, the application responds back. And there could be another application lying on the ECS cluster that could be polling an Amazon SQS queue. So if there is a new message in the SQS queue, it's going to process that message, and it's going to basically respond back, right? So think about this as your long-running traditional application that's running on the Amazon ECS cluster. Now, if you have to scale this application, like if there is a sudden influx of requests coming to your long-running traditional application, you'll be scaling out this application. And long story short, if you get a request, or if the application is serving some request, or if it's idle, if it is not getting any requests, end of the day, you're going to be paying for the compute that's lying there, right? The long-running traditional application that's running on the ECS cluster. On the other hand, you have the serverless application, and the serverless application can itself, interact with other serverless applications. Like, it could, the function that's running on the Lambda can be interacting with EventBridge. It could be using step functions. It could be using SNS. But let's think about the same request-response-based application that's running on Lambda. A new HTTP request comes. API gateway sort of intercepts that request, and it triggers an event, right? It triggers an event that launches the Lambda function. You get another request, and another event is triggered, and the Lambda function is again initiated. So what's the difference here? Like I said, the traditional application on the ECS continues to run until you terminate it. So you got to pay for the application unless and until it's being, it's lying there on the ECS cluster. On the other hand, So the Lambda or the event-driven serverless application is, you only pay for that application when there is an event occurs, like if there is a new HTTP request that hits your API gateway. How do I think about Lambda, ECS, or Kubernetes? How do I pick the right orchestrator service for launching my container image? Again, this is a whole different perspective, guys. I'm going to take you through the AWS API perspective. Now, with Lambda or Amazon ECS, you have the set of AWS APIs. So you could use those APIs to deploy the cluster, and eventually you can use the same APIs to even deploy your application, right? But with Kubernetes, it's a little different. You could use the AWS APIs to deploy the Amazon EKS cluster, but in order to deploy your applications, in order to deploy your long-running traditional application, Nginx or Tomcat, right? You got to use the Kubernetes APIs. You cannot use the AWS APIs to interact with the Kubernetes cluster and deploy your application. That's where Kubernetes is kind of different from the other orchestrators like the Amazon ECS and Lambda. So let's say if this application has to use other components like load balancers, or it needs EBS volume to be attached or an EFS volume to be attached. The way we kind of do it is there is a mapping that you can do between the application and the AWS resources using drivers, daemon sets, operators. So by using these objects in the Kubernetes cluster, you could do a mapping between your application and the load balancer, or be it your EBS volume, and have them consumed by your long-running traditional application. Now, this is how it's kind of different in terms of the AWS APIs we have. Now, let's answer the important question, right? Which orchestrator should I choose for my use case? The way we've seen is Amazon ECS works very well. It's a great fit for those long-running traditional applications that pretty much don't change through its entire life cycle, and it requires low operation efforts. So Amazon ECS is a great fit for those traditional applications that requires low operation efforts and that doesn't change much. And an added advantage is that if this application has to interact with other AWS services, we've seen it perform very well with Amazon ECS, because Amazon ECS itself is natively integrated with other AWS services. So bottom line, you have the long-running traditional application that requires low operation efforts and that has to interact with other AWS services, then Amazon ECS is a great orchestrator, great way to launch your container image on AWS. And when do I use Lambda? So with Lambda, your operation efforts are furthermore reduced, right? Because you don't have to manage the capacity. AWS takes care of managing the capacity for you. So your operation efforts are further reduced. And we seem to, we've seen customers doing well with new applications, any new applications, definitely not a long-running traditional application, because Lambda is event-driven. It's a serverless way of running. I mean, yes, you can run a long-running traditional application on a serverless platform, but Lambda is event-driven. That kind of prevents your long-running traditional application from getting into Lambda. So any new applications that requires further, less operation efforts, Lambda is a great fit. Now, when do I use Amazon EKS? Again, guys, whenever I speak about choosing appropriate service to launch your container image, think about the dimensions always, right? So I spoke about flexibility and extensibility, right? So if you have an application and if I want to move my application to a different platform, how can I achieve that? That's where Kubernetes or Amazon EKS comes into picture. It is suited for long-running traditional application, which requires extensibility, which requires flexibility. So that's where we see Amazon EKS a great fit. Another way to choose your orchestrator, the right orchestrator, is by what we call a mean time between updates. Basically means that how long can I run my application without touching the infrastructure where it's running? Quick show of hands, how many of you guys have those Lambda functions that you created like years back, and one fine day you log into your Amazon Lambda console and you still see that function running, right? Basically means that you don't have to manage the infrastructure itself. So how long can I run my application without touching the underlying infrastructure? That's where Lambda plays a bigger role. So another way to choose your orchestrator is by keeping this dimension in mind, which is mean time between updates. Because if you're using Amazon ECS and Amazon EKS, your operations team is going to find some time, or they'll have to allocate some time to upgrade their clusters, to make sure that they keep up with the latest releases that we announce with Amazon EKS or Amazon ECS. So there's going to be a considerable amount of time that's going to be spent in upgrading this environment. We are going to help you with upgrading these clusters, but still there is considerable amount of time that your operations team has to allocate. Now, another way to kind of select the appropriate orchestrator is by keeping the second dimension, which is mobility and flexibility. Now, if you have built a serverless application on a Lambda, you are bound to the AWS infrastructure. Now, if you ask me, can I move this application to a different platform? My answer might be no, because you've built this application for Lambda, and it's good for Lambda. On the other hand, if you have an application running on Amazon ECS, can you now move this application to a different platform? Yes, right? Because end of the day, the container image that's used inside your Amazon ECS cluster is going to remain the same, be it if it runs on Kubernetes cluster or Amazon ECS, the container image is still the same. The choreography, the way you write this YAML files, the way you write the task definition files is going to differ. You'll have to spend some time refactoring the configuration, making sure that it works with the other platform, but you still can move this application to a different platform, meaning it is mobile and it can be flexible. With Amazon EKS, you can definitely move this application, right? Because the choreography, the configuration is also going to remain the same. The way you write your deployment config, the way you write your daemon set, pod, talk about the other objects, it's going to remain the same on Amazon EKS or on the other Kubernetes platforms. So it's another way of looking into selecting the appropriate orchestrator. Can it give me the mobility and flexibility that I have? Because my application is unique, it has some unique requirements, it has to run on multiple platforms. So can this particular container service help me meet that need? So this is one way of looking at, one way to think about selecting the right orchestrator service to launch your container image. Perfect. We saw the capacity layer. We saw the various options that we have on the capacity layer. We saw the orchestrator layer. We spoke about Lambda, Amazon ECS, Amazon EKS. We kind of drew those lines on where Amazon ECS can be a great fit, where EKS can be a great fit, and similarly, Lambda can help our customers launch their container image on AWS. Now let's talk about the provisioning products. If you recall, the provisioning layer is nothing but a set of API tools that can interface or interact with orchestrators to launch your container image on AWS. It kind of hides the abstraction. It kind of hides the richness or complexity of the orchestrator, making it easy for our customers to interact with our orchestrators, right? Now, how are our customers adopting, or how are our customers selecting the right provisioners to launch their container image? Again, we see two kind of approaches when it comes to selecting the provisioning layers. The first approach is where you have this team that doesn't have an ops team, an operations team that can support them in managing the cluster or the orchestrator. All they have is a piece of code, and they would want to deploy this code on the AWS environment and forget about where this particular piece of code is running. They don't have the bandwidth or the life cycle to manage this environment where this particular container image is running. An example is AWS App Runner, right? So if you use App Runner to launch your container image, you basically don't have to manage the infrastructure where your container image is running. It's a managed way of deploying your container image on AWS. Things happen on the AWS side, and for which you don't have access into or get visibility to, but the customer's needs, or the requirement of the customer is finally satisfied by having AWS App Runner, right? Now, the second kind of discussion we see is what I call the working backwards conversation, guys, right? So the so-called platform team, if you remember, who did the strategic analysis, they selected a particular orchestrator, right, in order to launch a container image. Now, developers look at this particular orchestrator selected by the platform team, and they try to navigate between the various provisioning tools and pick the one that kind of works well with this orchestrator. For instance, if you're using Amazon ECS, if your platform team has selected Amazon ECS as a way to deploy your container image, we've seen Copilot working well with our Amazon ECS cluster. So Copilot is a CLI tool which can be used to launch your container image on Amazon ECS. So developers will predominantly go with Copilot to deploy the container image on Amazon ECS. So these are the two patterns, these are the two discussions that we've seen with our customers when it comes to selecting the right provisioner for launching their container image. Now let's take a look at the various provisioner tools that we have and talk about their use cases, right, where it could be a great fit. We'll start with AWS App Runner. As I told you, AWS App Runner is a great tool. It's a managed way of running container image on Amazon ECS, right? So with App Runner, as you can see, these are all dotted lines. It's an easy way to run your request response based application, Nginx or Tomcat, your traditional long-running application. It can be easily deployed using AWS App Runner. And the dotted line means that everything happens on the AWS side, and you don't have visibility or you don't have to manage the infrastructure where your container image is running. Next up, we have Docker Compose. Again, Docker Compose, we've seen customers who are fully into Docker ecosystem leveraging Docker Compose to deploy the container image on Amazon ECS. The way it works with Docker Compose is you have a concept called context within the Docker Compose world. Basically, a context is nothing but you can create various profiles. If you want to deploy a container image on your local desktop, you might be creating a context for your local desktop. And similarly, you can create a context for your AWS environment where you basically configure your AWS credentials. So by using the appropriate context, you can deploy the container image on the respective AWS environment, or you could navigate between different platforms, be it your local desktop or even your AWS environment. Now, the way Docker Compose works is it basically creates a CloudFormation stack, and you can navigate to your AWS account. As you can see, these are solid lines, which means that activities happen on your account. So you can basically navigate to the CloudFormation console, and you could see the various resources being created when you initiate the Docker Compose up command, which basically deploys your container image on AWS. AWS Copilot, another a great tool, it's a CLI tool that is used to deploy your container image on Amazon ECS. Interesting thing to note about AWS Copilot is that we know Copilot is a provisioner tool, and as you can see, this provisioner tool interacts with another provisioner tool, which is AWS App Runner, to deploy container images on Amazon ECS. What this means is, down the line, AWS Copilot can act as your entry point to deploy your container image, not just on ECS, but we might be adding support for other container services as well, right? So think about Copilot as an entry point to deploy your container image on other services. Lightsail, that's another interesting tool, a provisioner tool that can be used to launch your container image. For folks who doesn't know what Lightsail is, Lightsail provides an intuitive way to run containers on AWS, guys. With Lightsail, I mean, if you're someone who doesn't want to know the richness of AWS services, the various features, various offerings that it has, Lightsail is a great way to start. It was initially a service to provision your VMware environment, but it added support for launching your databases as well. Now, Lightsail also lets you run container image on AWS. So with Lightsail, everything is bundled together as a single package in terms of billing, right? So you select the appropriate CPUs, you select the appropriate memory, and you select the container image that you would want to run on AWS, and you get a single bundle. You don't pay for pay as you go model. You get a single bundle with the this is what you're looking at a monthly when you use Lightsail to launch your container image. So Lightsail works great if you don't want to understand the richness of the AWS services. It's a great way, it's an intuitive way to run container image on AWS. Again, with Lightsail, as you can see, these are dotted lines, so you don't have to manage or you don't have visibility into what's happening behind the scenes. Again, it works well for the simplicity dimension, right, where you don't have a strong ops team that can help manage the cluster, help manage the environment. You have a piece of code, and you would want to deploy this code as soon as possible into the AWS environment. That's where Lightsail can be a great fit. AWS Batch, this is another vertical universe that we kind of built on top of Amazon ECS, guys. So with Batch, it's specifically designed for scheduler type of workloads, batch kind of workloads that can be deployed using Batch on Amazon ECS cluster. Now the way to kind of, what we've seen is that customers asking us, they could directly use Amazon ECS to deploy this batch or scheduler kind of workloads on Amazon ECS. The way to kind of answer that question is, with batch, you don't have to reinvent the wheel. If you specifically have a scheduler type of workload or batch type of workloads, with batch, you get all these features right off the bat, but if you are using ECS to deploy the same type of applications, you'll have to reinvent the wheel to launch your scheduler or a batch kind of workloads on Amazon ECS. Again, it's a solid line, which means that you have access to what's happening. You get to know what's happening, what resources are being provisioned when you use batch to deploy your container image on AWS. AWS Amplify. Again, we spoke about AWS Amplify a bit in our previous slides. We've seen customers picking Amplify to launch their container image, not just because it lets you run container image, right? You might be having other application components like your front-end application or your mobile application built using Amplify, and customers might feel it comfortable to use Amplify, and once they are familiar with Amplify, they might even leverage the service to launch the container image on AWS. That's how we see customers picking Amplify to launch container image on AWS. And again, Amplify can also initiate, or it can launch a Lambda function. Again, another example of a provisioner interacting with another provisioner to deploy your container image on AWS. Elastic Beanstalk, another way to deploy container image on AWS. Now with Beanstalk, think about, again, the simplicity dimension, where you have a piece of code, you don't have a strong ops team, they would want this piece of code to be deployed on the AWS environment. Now Elastic Beanstalk is a great fit for such use cases, right? As you can see with Elastic Beanstalk, there is not even an orchestrator that's in picture. Elastic Beanstalk kind of interacts directly with Amazon EC2 to deploy your container image on the AWS environment. So the way we see, or the way we see how customers picking Elastic Beanstalk to deploy the container image is that they don't choose Elastic Beanstalk just because they want to use it. We've seen customers using Elastic Beanstalk to deploy the container images because they've used that service extensively. They know what Elastic Beanstalk is. They know how to use it. And that's probably why they have picked Elastic Beanstalk to deploy the container image on AWS. IoT Greengrass. So if you want to basically deploy your container image on edge devices, AWS IoT Greengrass is a great provisioner tool that you could leverage. The reason why I kind of added this provisioner tool in the slide is there seemed to be a comparison between ECS Anywhere and IoT Greengrass. Which service? Because ECS Anywhere also allows you to also allow you to launch container image on the edge devices. So if you ask me how to pick the right provisioner tool for launching container image on the edge devices, I would probably ask my customer that if this particular deployment is part of a big IoT project. Then if the answer is yes, probably IoT Greengrass is the way to do, right? Because it's basically part of a bigger IoT project, and it makes more sense to use IoT Greengrass to deploy your container image on the edge devices. On the other hand, if it's just like a POC, if it's a model deployment that you're trying to do on edge devices, probably you could leverage ECS Anywhere. So if you notice, all these while, we've been talking about some of the provisioner tool that interacts with Amazon ECS cluster. We haven't seen any provisioner tool for Kubernetes cluster. The reason being, Kubernetes itself is backed by a rich ecosystem, guys. So there is tons of provisioner tools that works well with Kubernetes system or Kubernetes cluster, and hence, we don't have an opinionated provisioner tool that we recommend our customers to use when it comes to deploying their container images on Amazon EKS or Kubernetes cluster, right? We're not ruling out the fact that we'll not be coming up with some opinionated way, but at this moment, we've seen customers using the existing provisioner tools that can work very well with the Kubernetes cluster to sort of deploy their container images on Kubernetes ecosystem. All right, guys, as we are nearing the end of the session, let's answer the million-dollar question, right, which is, can I tell my customers authoritatively that given their requirements, given their use case, this could be the right container service for you to launch the container image? Now, we are thinking about a prototype that might make our customers easy to consume or easy to select a AWS service to launch a container image. Now, we are thinking of something like a product scorecards. If we can throw a number of questions to our customers, basically around the dimensions, right? Think about workload types. Can my workload type, can it run on, is it flexible? Do I need to move my workloads between different platforms? So the so-called service, the container service, can it support this particular dimension? Think about capacity. Is my workload specifically designed for Amazon EC2, or it can also be run on Fargate? Think about ease of consumption. Can my developers consume this provisioner tool? Can they easily deploy the container image on Amazon or on AWS? So help me pick a service that can meet this particular requirement. Ease of operations. Again, guys, please bear in mind that ease of consumption and ease of operations are two different things, because what might seem to be easy for you to consume might be difficult for your operations team to perform their day two operations, right? Basically, I'm talking about managing this cluster, upgrading this cluster, patching this cluster. So it's going to take a considerable amount of time to manage this day two operation. So the so-called container service, is it easy to operate? Is there a specific, or is there a managed way of maintaining this cluster? Extensibility. Is my product, my application has some unique requirements. So is this particular container service, does it provide extensibility? Hybrid support. So when I talk about hybrid support, your security requirements or your compliance requirements might want you to make this application run on different platforms. So can this particular container service guarantee the hybridity? This is one of the key criteria that I have to pick a container service. Ecosystem, we were talking about the Kubernetes ecosystem. Is this particular container service backed by a rich ecosystem? Because I don't have to reinvent something if I need to extend my product, if I need to kind of think about scaling my application. Is it backed by a rich ecosystem that out of the box gives me numerous ways to scale my application, right? So if the customers can answer these set of questions, we are thinking of creating a product scorecard like this, right? Again, a disclaimer, I don't want you guys to think about Amazon ECS is great here, Amazon EKS is great here. It's more of a prototype that we are thinking in our mind that can help our customers select the right container service for launching their container image. So basically, if you have answers to the previously asked dimension-based questions, we'll try to kind of help our customers select the right container service to launch their container image. So coming back to the checklist, right? Is it possible for me to build a checklist to launch or land my Boeing 747? It's not easy. There's a huge risk and challenge involved there. But if we know where our customers are coming from, if we know the various dimensions, if we know what matters most for our customers, is it the extensibility, or is it the flexibility, or is it the hybridity? If you are able to understand their requirements and try to know where they are getting into, we might be able to build something like this to help our customers pick the right container service to launch their container image. So basically, it might be looking like this. Let's say our customer is a startup customer, would want to deploy a web service using AWS APIs, and it's a traditional long-running application, and the operations model should be super easy. Then we say AppRunner is a way to do, because with AppRunner, you don't have to manage the underlying infrastructure, right? All you have to do is just deploy the code, and AWS will take care of selecting the right platform to deploy your code, and we ensure that it continues to run. On the other hand, if you're someone who's looking into a serverless-based application and easy to manage, then we say Lambda is a way to do, because with Lambda, you don't have to, again, manage the infrastructure where your application is going to run. And this being a serverless application, makes more sense to use Lambda to launch your container image, because Lambda also allows you to run container image on AWS. So this is what we have in mind. This is what we are thinking about. So please feel free to let us know if you have some feedback or comments to this prototype. It would help shape this particular prototype and make it easy for our customers to pick a particular container service to launch their container image. Before I end this session, I want you guys to take a quick look at some of the digital courses that we offer and certifications that you could probably take depending on your domain. And with that note, I thank you all for joining today. Again, if you have some questions, if you have feedback, or if you have more comments about the prototype that we are talking about, feel free to reach out to us. And do take a few minutes to complete the survey. It's going to help us come up with more interactive sessions and more innovative sessions for our customers. We have 10 minutes for Q&A. If there are any specific questions.
Yeah, I got a question.
Yeah, sure.
Is it on? Yeah, so I know Docker Engine has been deprecated for Kubernetes and EKS. Is it still being used by ECS?
Did you say Docker Engine? Amazon ECS, the way to kind of think about it is it's an orchestrator. If you are specifically looking for a container runtime, we use Containerd, and we were previously using Docker. I'll have to double check that, but yes, we could be using Docker as a runtime to launch the container images. Yeah.
Okay, so one more question.
Sure.
The division between ECS and EKS responsibilities and Fargate. So Fargate, if I understand correctly, it is the one that will create clusters and all that kind of stuff, right? So which one is responsible for allocating pods or tasks? Is that the EKS and ECS, or is it the Fargate?
Again, like I said, Fargate is a way to run, it's a compute platform where your containers are running. So don't think about Fargate as an orchestrator which plans or which models your application and deploy them as tasks or pods. It's always the orchestrator which plans that and basically deploys that on the Fargate environment. The way to see Fargate is that it's a managed compute engine where you don't have to manage the cluster. We take care of making sure your container runtime stay up to date, and even the critical libraries and binaries are up to date. So when it comes to scheduling the pod, scheduling the tasks, it's always the orchestrator. Yeah.
I have a question regarding AWS Copilot and AWS.
Can I answer this, gentleman, and then get back to your question?
Yeah, two questions. The first is one of the last slides towards bottom, there was server and EC2.
Okay.
Two different shows.
Yeah.
I'm just wondering.
So like I said, again, getting back to the capacity platform, right? You have various places to run container images, one being Amazon EC2, right, which is on the AWS world. And servers, why we have explicitly stated server as a separate entity is that with EKS Anywhere and ECS Anywhere, you can use the same APIs to deploy images on your on-prem infrastructure. So server here means that your on-prem servers where you can deploy the images.
Thank you.
Yeah.
And the other thing was you were talking about the Docker Compose, and I believe that's a general Docker Compose. There is nothing specific about.
Yeah,
right?
Nothing specific. It's the same Docker Compose, configuration that you have, and use that to deploy images on Amazon EC.
Thank you. Good session.
Thank you.
I have a question regarding the deployment of container images. So you can either use AWS Copilot or CDK, right? The CDK can also be used to generate the CloudFormation templates for deploying container. So can you recommend on which scenarios we use Copilot and in which scenarios do you use CDK?
So with Copilot, it's a great fit. See, if you have written a task definition file, right, you know how big it can be. It's 100, 200 lines of code where you define the task definition, you define your CPU memory requirements, and so on. So if you don't want to run or write these many lines of codes, you could use Copilot, which can, through which you can specify, okay, this is what I'm looking at. I wanted to add, a load balancer, add CPU units to be like 0.25, 2 gigs of RAM. So you don't have to write these set of codes. With Copilot, you can just specify specify, it's a nice CLI tool where you can directly specify your requirements and have your container images deployed on Amazon ECS. So that's where I kind of see the difference. I think with CDK, you still need the task definition file, right, if I'm not wrong. Yeah. Correct, you're right. Yeah, sure. Any other questions? Yeah. We have a question.
So it's kind of like a related topic. It kind of comes into, like when you're running like EKS, ECS, and you have servers behind there, you know, on one server you have multiple containers running, and they could be run for different tenants and different parts of your organization. Do you have any suggestions around the pricing model? Because, you know, when you're running on like a one server, like you used to be able to just like tag the EC2 instance and, you know, charge that to that organization. But with multiple containers running on an EC2, that cost breakdown becomes a little bit more difficult. Is there
You're talking about charging back your
charge it back, yeah.
specific BUs, right, business units on their consumption. Have you checked kube cost?
Yeah, well, right. So I guess we're currently using KubeCost,
Okay.
and you know there are some third-party tools. I was curious if there was anything native to like the AWS pricing services.
So one way to kind of look at this is probably you can have a namespace created for each of these BUs, and if you have some kind of quota set on these namespaces, that's one way of, you know, kind of charging back these teams by the usage of, you know, by looking at the quotas that you have on those namespaces, charging them back. It kind of gives you, it doesn't give you a clear or a direct way to kind of charge them back, but at least you know their limits and you kind of charge them based on that. But KubeCost, from what I've seen, have answered or satisfied what you've been asking for. So.
Yeah, KubeCost is working for us. It's just we have to come up with a. Yeah, we're looking for more like AWS native solution for
I'll take this back to our service team and see if they have something for this. But yeah, thanks. That's a great feedback. Any other questions, guys? Yeah, please complete the survey, guys. It's going to really help us out. That note, thank you so much for joining. If there are no questions, I hope to see you guys at another AWS event. Thanks for joining us.